Okay, so it says to factor trinomials in the form x squared plus bx plus c, find two integers with a sum of b and they're going to be a product of c. So they're going to add together to equal b, and then they're going to be multiplied to equal what c is. That sounds a little complicated, but it's not that bad. If you look at this example 1, this already worked out for you. B is 7 and C is 12. So the first thing you're going to do is you're going to list out all of the factors of C. So we list out all of the factors of 12. So I know to get 12, I can do 1 times 12, I can do 2 times 6, and I can do 3 times 4. So then I look at those factors and I add them up. 1 plus 12 is 13, 2 plus 6 is 8, 3 plus 4 is 7. And I see which one equals whatever B is. So which one equals 7? 3 and 4. Okay, so these are the factors I need to use. This is supposed to be like a little check mark right here. Okay, so these are the correct ones. So to write this in factored form, I'm just going to use these factors. I'm going to say this is x plus 3 times x plus 4. And that's my answer. So remember, the way to check this is to multiply these. We can use the full method. Multiply the first, x times x. The outside, x times 4. Inside, 3 times x. And then last, 3 times 4. And combine like terms. So, is that what I started with? Up here? Yeah. So then I did it right. It gets a little bit more complicated when you're dealing with negatives, but that really is all that's to it. How does it work? It's because the reason it's addition is because you're multiplying 4 times just the plain x and 3 times the plain x, and then you end up combining those like terms. And then your only constant is you multiply these two, the last terms. So that's why it ends up working. But that's also why it ends up being a little bit more complicated when you have a number in front of the x squared. Jackson?
So are the factors of C always going to equal like an x with B?
Yes, we're going to get to some where if there's not factors that add up to equal b, then we say it's prime. That's just the word you use to say it can't be factored. Like you can't break it up. But we don't have any yet, but we'll say they're prime. And then eventually we're going to have a way to figure out the prime ones. Do y'all remember that really complicated formula I showed you? With the negative a plus or minus square root b squared minus 4ac. That's what you end up using to work out the ones that are prime. This year? Okay, so let's do this next one together. So B is 11, C is 24. Do I need to find the factors of 11 or 24? 24. So this might help you remember. Factors has the letter C in it. We got to find the factors of C. The factors of 24. And then they need to have a sum of 11. Okay, so the factors of 24. I have 1 and 24, 2 and 12, 3 and 8, 4 and 6. So which one of these adds up to equal 11? Okay, 3 and 8. So these are the factors I need to use. So my answer is going to be, back over here, these are supposed to be the same variable. Pretend these are both these. That's just a typo. my answer is going to be D plus 3 times D plus 8. Do you think it matters which one I write first? No. Okay, remember this is just multiplication. Multiplication is commutative. It doesn't matter the order.
Wait, so which one is the answer? Would the answer just be x plus 3 times x plus 8, or would the answer be like the everything else?
The answer is just this part.
Wait,
So you don't have to actually write it out like
Like the check part?
d squared. Yeah.
No, that's just checking to make sure you're right.
Oh, that's just a check.
Yeah, you don't even have to do that every time. I would just do it like maybe on a tough problem or on a test or something. Christopher, do you have a question?
oh yeah, I just put D plus 8.
Yeah, that's fine. Okay, so the next one, this is where some of the negatives start coming in. In this problem, B is negative 12, C is 27. So think about, I'm going to have factors of 27, but I have to have a sum that's a negative number. So look what's in the table over here. Okay, remember when I multiply two negatives, I get a positive number. When I add them, I get a negative number. So you have to pay attention to things like that. If you go on the back, we can try one like that. But I did write a little hint on this one. I would always put your expression in standard form first. The standard form is highest degree to lowest. So then B is negative 22, C is 21. Okay, try this one on your own. So which two factors work? Negative 1 and negative 21. But those equal negative 22. So because these are negative, that means we're going to be using subtraction here. I'm going to say m minus 3. Oh, whoa, I'm sorry. My bad. M minus 1 times m minus 21. That's my answer. Hey, or if you had it in reverse order too, that's fine. Gabby, do you have a question?
I'm so confused.
Which part? Is it because they're negatives?
Yeah, because the negative and the sum of, I was like, I would have thought the negative was something. I did not know that at all.
Do you determine it to the factor that you end up
Yep.
Instead of adding
Okay, so example 3. In this case, we have B is positive 3, C is negative 18. So in this case, look at the factors here. We have negatives and we have positives because a negative times a positive equals a negative number. So you have to account for that when you're writing your table. I have negative 1, positive 18, negative 2, positive 9, negative 3, positive 6. And the one that works is right here. Negative 3, positive 6. Jeremiah?
So it's not it's always going to be the bigger number that is positive and the smaller number is negative.
Well, you see right here. I put since B is positive, the greater number will be positive.
Does that happen?
But when B is negative, the greater number will be negative. Okay, so in this next one, B is 13, C is negative 48. So I need factors of negative 48. And they need to have a sum of 13. Okay, so do I want my bigger number to be negative or positive here?
Positive.
Positive because the sum has to be positive. So I can try like negative 1, 48. No. Negative 2, 24. That doesn't work. Negative 3, 16. Does that work?
Yes.
Yes, that equals 13 when I add it. So these are my factors that are going to work. So now I can write the factored form. I have y minus 3 times y plus 16. The last, like, grouping in GCF.
The one with the equal sign.
That's like 8, 5.
Mm-hmm.
So these look like that one.
Well, these are going to have some equations too, but if you can do this part, then you can do the equations. Okay, so the last one, let's just go ahead and go to the last example. But notice this. In these, B is going to be negative, so the greater number must be negative. These parts, it's not really necessarily something that you have to memorize. It's just something helpful to notice. It may save you some time. So I'm looking for factors of negative 24. The sum of negative 2. Okay, so which factors work? Negative 6 and 4, so equal negative 2. So my answer is going to be R plus 4, R minus 6.